Okay, so in this video I want to go over how we can solve different types of quadratic equations. And so quadratic equations, they take this form. So we have ax squared plus bx plus c is equal to 0. So that's the idea. You want to get your equation into this form ideally, and then if an equation is in this form, then you can solve it by factoring. So this type of equation, the quadratic equation, is extremely common in algebra, and it has applications everywhere. So you'll be seeing it a lot, especially if you're going into some sort of STEM major. This equation shows up everywhere. So it's very important that you know how to solve for it. So I'm going to go through a bunch of examples today to show you the different methods in which we do that. So the first one that I'm going to look at today is, let's do 15 plus x minus 2x squared is equal to 0. Okay, so the first thing that I'm going to do right off the bat is I'm going to get this into standard form. So standard form just means you have the highest degree term first and all the subsequent degree terms following after it. So to write this in standard form, I've got minus 2x squared plus x plus 15 is equal to 0. And another thing that's convenient to do, because it makes picking the factors a bit easier, is to basically divide out a negative if your x squared term has a negative coefficient, which it does. So what I'm going to do is I'm going to divide everything through by a negative. And this is legal because 0 divided by a negative is still 0. So when you do that, you effectively switch the signs of all of the terms on the left side. So I'll have 2x squared minus x minus 15 this time. Set that equal to 0. Okay, so now that I have a positive coefficient in front of the x squared and everything is in standard form, then I'm good to go to try to solve this thing. So the first method that I'm going to try out is the method of factoring. And this is why it was so important to learn about this in the algebra prerequisites, is factoring these types of equations so that you can eventually solve for them. So what I'm going to do is I'm going to reverse FOIL this. So I'll have 2x and x as my factor pairs, and the idea is to find two numbers that multiply together to get negative 15 and add together to get negative 1. Okay, so I notice that if I use the factors 3 and 5 here, if I have a positive 5 right here and a negative 3 right here, if I FOIL this out, I'm going to get the exact equation that I have over here. So I know that this is the correct factor pair. So if you need help with factoring these quadratic equations, or just any sort of expression that looks like a quadratic, I made several videos covering this in the algebra prerequisites playlist. So if you have trouble, I would recommend checking out that playlist so that you can get solid on this. So we're going to take this a step further. So notice that we have two terms multiplied by each other. We have a 2x plus 5 term and an x minus 3 term. So the way that we can guarantee that this equation equals 0 is if one of these factors is 0. At least one of these factors is 0. Because if we set 2x plus 5 equal to 0, well then we'll be left with 0 times x minus 3. And 0 times anything just gives us 0. So that's why we set each of these factor pairs equal to 0, because it guarantees that we're going to have an equivalent equation. So the first thing I'm going to do is set 2x plus 5 equal to 0, and I'm also going to set x minus 3 equal to 0. And when we solve for x in these two linear equations, it's going to give us the values that are going to return a 0 when we plug it back into the original equation. And now those are going to be our solutions. So the first one, 2x minus 5 is equal to 0. I add 5 to both sides, and I get 2x is equal to 5, and then I divide by 2, and I get x is equal to 5 over 2. And this is my first solution to this. So it's nothing more than just factoring it, which we've done before, and then setting each of the factors equal to 0. And in this one, all I got to do is add 3 to both sides. And then I get x is equal to 3. Okay, next example I have is 2x squared minus x minus 28 is equal to 0. So notice that this equation is already in standard form, and I already have a positive coefficient in front of the x squared term, so I can go directly into trying to factor this thing. So it's going to factor in this fashion, and the idea is to pick two numbers that multiply together to get negative 28, and that will also add together to get negative 1. So fortunately for us, 28 doesn't have too many factoring pairs, so I can try a plus 7 here and a minus 4 here. So if I FOIL this back out, I'm going to get this original equation here, which is what we're looking for. And then the next step that we're adding is to set each of these factors equal to 0. So I'll have 2x plus 7 is equal to 0, and I'll have x minus 4 is equal to 0. And then we just solve these linear equations. So I am going to subtract 7 to both sides. So I get 2x is equal to negative 7, and then divide by 2. And I get x is equal to negative 7 over 2. That's my first solution to this equation. And then for the last one, I just add 4 to both sides, and I end up with x is equal to 4. And that's all there is to it. So if you get it in standard form, the first thing that you should try is to see if you can factor that equation. Reverse FOIL it. And if you can, then you just got to set those two factors equal to 0 and then solve for x separately in these two equations. So we're only really adding one extra step from the factoring technique that we already learned. Okay, so let's say I had something like this. Let's say I had 6 is equal to 3x squared. So in this instance, we don't really have an x term, right? So what we're going to be doing is sort of an adaptation of the difference of two squares. So when you have no middle term here, you can solve for x directly by a method that we call extracting square roots. So this is how I'm going to do it. First of all, I need the coefficient in front of the x squared to be 1. So to do that, I'm going to divide both sides by 3. So I get 2 is equal to x squared. So now here we go. What cancels the x squared? Well, a square root does. So what we're going to do is take the square root of both sides. And then I'm going to get x is equal to the positive and negative square root of 2. And that's it. So you might be wondering why I have the positive and negative here. Well, first of all, I have an x squared, so I'm going to have two solutions. But notice what happens if I plug in the positive and negative square root of 2. So I have 3 times the positive square root of 2 squared. Well, the square root and the square cancel, so I'm just left with 3 times 2, which gives me 6. No big deal. But if I plug in a negative square root of 2, does it the same thing happen? Because guess what? All I'm really saying is negative square root of 2 times negative square root of 2. I got a negative times a negative. That's going to give me a positive 2 also. So this is 3 times 2, which is also 6. So that's why we have the positive and negative here, because it doesn't matter what the sign is of any number that you're squaring, because if you multiply a negative by another negative, you're going to get a positive. Okay, let's do another example of extracting square roots. So let's say that I have 16x squared is equal to 25. So again, first things first, I want to get the coefficient in front of the x squared term to be 1. So to do that, I'm going to be dividing both sides by the 16. So I end up with x squared is equal to 25 over 16. And so to get x completely alone by itself, I just take the square root of both sides. And I end up that x is equal to positive and negative 5 over 4. So again, recall that I can rewrite this root here, 25 over 16, as a fraction of the roots. So I have the square root of 25 over the square root of 16. And of course, the square root of 25 is just 5, and the square root of 16 is just 4. And I still have that positive and negative based on what I showed you in the previous example. You have to have the positive and negative version, because if you plug them either of them in to the original equation, you're going to get a true statement. Okay, let's go through another example. So let's say that I had x plus 13 squared is equal to 25. So this one looks a bit funky. So there's a couple of ways that you can do it. You could FOIL this left side out and then subtract 25 over to get it into standard form and then see if you can factor that equation. But to be honest, that's a little bit too much work. A little bit too much work for me. So if I have it in a form like this, notice I don't have an x term directly. There's no bx term to worry about. So when you don't have a bx term, you can do the method of extracting square roots once again. So notice I have this entire thing squared, so what I can do is I can take the square root of both sides still. And when I do that, the square root and the second degree exponent cancel. So I'll have x plus 13 is equal to plus or minus, remember that plus or minus, the square root of 5. Or not the square root of 5, but just 5. But in this case, I only have one more step I need to do. So to get x completely alone, I subtract 13 from both sides. So x is either equal to 5 minus 13, or x is equal to negative 5 minus 13. So that's where the plus and minus comes in, and these are the two equations that we end up solving. So when I solve this, 5 minus 13 is negative 8, so I have x is equal to negative 8, and negative 5 minus 13 is negative 18, so I have x is equal to negative 18. So let me show you that this works. So if I plug in negative 8 into the original equation, I've got negative 8 plus 13 squared. Well, negative 8 plus 13 is 5, so I really have just 5 squared, which gives me 25, what I had on the right side. So that checks. And if I have negative 18 plus 13 squared, well, negative 18 plus 13 is negative 5, and negative 5 squared is also 25. So that's why extracting square roots works for an equation that looks like this too. There's no middle term to worry about. Let's say that I had the equation x squared plus 12x is equal to negative 25. Okay, fair enough. So what I'm going to do is I'm going to get this over to standard form by adding 25 to both sides. So I have x squared plus 12x plus 25 is equal to 0. So the next thing that I'm going to do is see if this factors. So it's going to factor into something like this because the coefficient in front of x squared is just 1. And the possible factors of 25 are pretty limited. I know that 1 plus 25 definitely isn't going to give me 12, and 5 plus 5 also isn't going to give me 12. So we have run into a problem. We can't use factoring for this because there aren't any factor pairs that are going to work when I FOIL it to get the original equation back. So I have to resort to method 2. So I also notice that I have this term in there, so I can't use the extracting square roots method. So I have to resort to method number 3, which is called completing the square. Okay? So completing the square is basically a way to convert something that looks like this into something that looks like this. Or like x plus b squared plus c. So we're trying to convert a standard form equation into an equation in which we can use extracting square roots. And that's all we're really doing. So I'm going to rewrite this. So I got x squared plus 12x is equal to negative 25. And so we have to do a little bit of creativity here. So recall that if I have some sort of binomial expansion and I square it, this is equal to a squared plus 2ab plus b squared. It's not equal to a squared plus b squared. It doesn't distribute this way because what I'm really saying is I have a plus b times a plus b, and this is a FOIL. So if I FOIL this out, I'm going to end up getting a squared plus ab plus AB plus B squared. And that simplifies to this equation right here. Okay, so what I'm going to do is I'm going to manipulate the left side of the equation to look like this form right here. I want to get it into something that's this form. So I have to choose my A and my B carefully so that I can then convert it into something that looks like that. And the number that you pick is going to be designated by the formula B over 2A squared. So this is how you pick the number that you're going to add and subtract. So B over 2A squared is equal to 12 over 2 squared, which is equal to 36, because 12 over 2 is 6, and 6 squared is 36. So this is what we're going to do. We're going to have x squared plus 12x, and then we're going to add a 36. And then we're going to add a 36 to both sides. Whatever you do to one side, you got to do it to the other, right? So this is what we have. So notice that I have the left side of the equation into this form right here. And so now I can use that equation that I have, a plus b squared is equal to a squared plus 2ab plus b squared, to convert the left side. So this converts into x plus 6 squared. Because if I set 12x equal to 2ab, divide both sides by 2, and I get AB is equal to 6x. So I know that A is equal to 6 and B is equal to x. Or vice versa, whichever way you want to do it. Doesn't matter. And then on the other side of the equation, I just have 36 minus 25, which is going to give me 11. So check it out. This is the method of completing the square. We're just converting an equation that's in standard form into a form in which we can employ the extracting square roots method. So in the last example, I showed you guys how to do the extracting square roots. All you got to do is take the square root of both sides, and what you're left with is x plus 6 is equal to plus or minus the square root of 11. And then that's going to leave you with two equations. So I have x is equal to negative 6 plus the square root of 11, and negative 6 minus the square root of 11. And these are your two answers. So notice it would have been very difficult for us to figure out that these were the factors that we were looking for without this method. So completing the square is very useful whenever resorts 1 and 2 don't work. If you can't factor it, and if you can't use the method of extracting square roots, then default to completing the square. Okay, so let's go through another example here. Let's say that I had 9x squared minus 12x is equal to 14. Okay, so right off the bat, I'm seeing that I have some pretty ugly coefficients here, but I'm going to try to get this into standard form. So I got 9x squared minus 12x minus 14 is equal to 0. And of course, the first thing that I'm going to do is I'm going to try to factor it. So I'm going to see that I've got this type of factorization to start. I'm just speculating. And it turns out that there is not any sort of factorization pair that we can use that's going to give us the original equation. So we have to resort to other methods. So completing the square is really only helpful if the coefficient in front of x squared is a 1, because that makes the binomial expansion a bit easier to work out. But since it isn't 1, we have one last trick up our sleeves called the quadratic formula. So the quadratic formula, I'm going to write it over here, is negative b plus or minus the square root of b squared minus 4ac divided by 2a, where a, b, and c are the coefficients in your quadratic equation standard form. So 9 is a, negative 12 is B, and negative 14 is our C. So I only use the quadratic formula when the coefficients are really ugly and nothing factors out, such as the case that we have here. And all the quadratic formula is just completing the square in the general standard form of a quadratic equation. And I can make a separate video about that, where that formula comes from, but for now, all you have to do is just plug in the numbers. So I've got x is equal to negative b, so this would be positive 12, plus or minus the square root of b squared, which is 144, minus 4ac, so 4 times 9 times negative 14. Make sure you leave all of the signs in place because it's very important. Times 2a, so 2 times 9, which is over 18. And so when I crunch the numbers for this, so I get x is equal to 12 plus or minus 9 times the square root of 8 divided by 18. And the square root of 8, you can write it as square root of 4 times 2, and that simplifies to 2 root 2. So we'd have 12 plus or minus 18 times the square root of 2 divided by 18. And if I factor this out and simplify it, I've got x is equal to 2 over 3 plus square root of 2, and I've got x is equal to 2 over 3 minus the square root of 2. So again, it would be very difficult to pick out these factors just directly. However, with the use of the quadratic formula, it makes it pretty easy for us to solve for x whenever we have really ugly coefficients. So let's say that I had negative 2x squared minus 5x plus 27 is equal to 0. So again, I don't like having negative coefficients in front of my x squared. So what I'm going to do is I'm going to divide through by negative to start. So I've got 2x squared plus 5x minus 27 is equal to 0. So all I do is change all the signs whenever I divide through by a negative. And so, since we have it in standard form, I'm going to see if this is factorable. So I've got 2x times x is equal to 0. And then for our factor pairs, I'm going to try 9 and 3. And notice that we don't have any sort of factor pairs that are going to work out for this. So we're going to have to resort to either completing the square or using the quadratic formula once again. So you could use completing the square, but then you'd have to do some operations with fractions and carry out those operations. So whenever you see a coefficient other than 1 in your standard form equation, it's just convenient to use the quadratic formula again. So I have x is equal to negative b, which is going to be negative 5, plus or minus the square root of b squared, which is 25, minus 4ac, so 4 times 2 times negative 27, divided by 2a, which is 2 times 2. So x is equal to negative 5 plus or minus, so 4 times 2 is 8, and 8 times 27 gives you 216. So what this is going to give you is x is equal to negative 5 plus or minus the square root of 241 divided by 4. So 241 is a prime number, so we just leave it inside the root. It doesn't have any sort of perfect square factors. So x is going to be equal to negative 5 over 4 plus the square root of 241 over 4 and x is going to be equal to negative 5 over 4 minus the square root of 241 over 4. So this is a convenient method to go straight to the answer for any sort of quadratic equation that you have, if the coefficients are ugly. Because if they're not ugly, then you can use one of the other methods and it would be able to be solved faster, and you wouldn't have to crunch stuff in your calculator. Okay, this is the last example that I'm going to go through for today. So it's going to be negative 20 minus 3x minus or plus 3x squared is equal to 0. So I'm going to rearrange this so that it's in standard form. So I got 3x squared minus 3x minus 20 is equal to 0. Just looks a little bit cleaner. So then I'm going to see if I can factor this. So it'll factor into something that looks like this, because the factors of 3 are just 3 and 1. So I got to pick factors of negative 20 that when I plug them into this factored form, I can get a FOIL product out such that the middle term is negative 3x. So my factor choices are, I'm not going to say it's too limited, but if I do 10 and 2, I can get it to negative 4x, so that's not going to work. And if I have 4 and 5, I can't get close to it. So unfortunately, there's no way to factor this. So I'm going to have to resort to the quadratic formula once again, because my coefficient in front of the x squared term is not 1, and it's going to bring some trouble whenever I go to complete the square a bit later. So I'm going to have to resort to the quadratic formula once again. So I have x is equal to negative b, which is going to be a positive 3, plus or minus the square root of b squared, so negative 3 squared, minus 4ac, so 4 times 3 times negative 20, all divided by 2a, so all divided by 2 times 3. So x is equal to 3, plus or minus, so I have 9 minus, so I have 9 plus 240 in there, which gives me the square root of 249 divided by 6. And 249 does not have any sort of perfect square factors, so I can't simplify that root anymore. But what I end up with is x is equal to 1/2, because 3 over 6 is 1/2, plus the square root of 249 over 6, and x is equal to 1/2 minus the square root of 249 over 6. Alright, so I hope this video was comprehensive and helpful to give you some examples of how we use different methods to solve different types of quadratic equations. So did a few where I factored, and did a few of extracting square roots. I think I did one, complete the square, and then also showed you the quadratic formula. And in a separate video I can show you where that formula comes from, because a lot of students really think it's dumb to memorize it with a song. But I've come to find that if you know why the formula even works, then you'll find it more worthwhile to use and actually have some meaning behind it. So again, thanks for watching this video. I hope that it was helpful, and please stay tuned for the next one.